Deconstructing modular, the building blocks of tomorrow. Modular construction, in simple terms, is a rather clever way of putting buildings together. Think of it like a giant, sophisticated set of building blocks, but for grown-ups. Instead of building everything piece by piece on the site, under the sun and rain, large parts of the building are made in a factory. These parts are called modules. These modules are complete sections, sometimes even entire rooms, fully fitted out with electrics, plumbing and finishes. It's a highly controlled process, much like manufacturing a car. The precision involved is quite remarkable, ensuring every component fits just so. This method is transforming how we think about creating spaces, from homes to hospitals. The basic components of modular construction are these factory-built units. These aren't just empty shells. They can be incredibly detailed. Imagine a bathroom module, complete with tiles, fixtures, and even the mirror, all installed before it ever leaves the factory floor. Or perhaps a section of an office building with walls, windows, and ductwork already in place. These modules are then transported to the construction site, often by lorry. Once they arrive, they are carefully lifted into place by cranes and joined together. This assembly process is surprisingly quick, making it a fascinating spectacle to watch. The connections between modules are engineered to be strong and seamless, creating a robust and unified structure. One major type of modular construction is known as volumetric construction. This is where entire three-dimensional modules, essentially room-sized boxes, are produced. Each module is a self-contained structural unit. When these volumetric units are brought to the site, they are stacked or placed side by side, much like Lego bricks, to form the complete building. This approach is fantastic for projects where speed is absolutely crucial, like student accommodation or hotels where many repetitive units are needed. The level of completion within these volumetric modules can be very high, meaning less work is needed on site, which really cuts down the overall build time. It's a truly efficient system. The other prominent type is panelized construction. Here, instead of complete three-dimensional boxes, large flat panels are manufactured in the factory. These panels could be walls, floors, or roof sections. They arrive on site as a kit of parts ready to be assembled. While it's not as plug-and-play as volumetric, panelized systems still offer significant advantages over traditional building. The panels are made to precise specifications, ensuring a good fit and high quality. This method allows for a bit more design flexibility on site compared to volumetric, as the internal spaces are formed as the panels are connected. It's a clever compromise, offering factory precision with some on-site adaptability. The upsides: why modular is gaining momentum. One of the most talked about benefits of modular construction is the incredible speed it offers. Because the modules are built in a factory at the same time as the site preparation work, like laying foundations is happening, the overall project timeline can be slashed quite dramatically. We're talking reductions of up to 50% in some cases. This isn't just about getting the keys sooner, it means less disruption on site, fewer months of financing costs, and a quicker return on investment for commercial projects. For anyone who has endured a long, drawn-out traditional build, the appeal of this swiftness is undeniable. It's a game changer, really. Then there's the efficiency and improved quality. Factory environments are controlled spaces. Workers are not battling the weather. No rain delays, no scorching sun affecting materials or productivity. This leads to more consistent workmanship and higher quality control standards. Every module can be inspected thoroughly before it leaves the factory. Furthermore, the repetitive nature of tasks in a factory setting allows for specialization and optimization, reducing waste and errors. This controlled environment also means better protection for building materials, which are not left exposed on an open site. It's a more organized, streamlined approach to building, plain and simple. Sustainability is another big plus point for modular construction. The factory-based manufacturing process allows for more precise material usage, which means significantly less waste compared to traditional on-site construction. Any waste that is generated is often easier to manage and recycle within the factory setting. Moreover, the controlled construction environment can lead to tighter building envelopes, meaning better insulation and energy efficiency in the finished building. This means lower heating and cooling bills for the occupants and a smaller carbon footprint overall. Many modular companies are also exploring the use of sustainable materials, further boosting the green credentials of this building method. Finally, let's talk about cost effectiveness. While the initial outlay for setting up modular manufacturing facilities can be high, the overall project costs can often be lower. The speed of construction means reduced labor costs on site and shorter project management periods. The reduction in material waste also translates to savings. Furthermore, the predictability of factory production means fewer unexpected delays and cost overruns, which are all too common in traditional builds. This cost certainty is incredibly attractive for developers and clients alike. It allows for better budgeting and financial planning, making ambitious projects more viable. It is a very sensible way to manage resources. Modular in action, diverse applications and smart tech. The versatility of modular construction is truly impressive, finding its place in a wide array of building types. In the residential sector, we see everything from single-family homes to large multi-story apartment complexes being built using modules. These aren't just basic boxes either. Architects are creating some wonderfully innovative and aesthetically pleasing modular homes. For commercial buildings, modular methods are used for offices, retail spaces, and hotels, where the speed of construction means businesses can open their doors and start generating revenue much faster. It's proving to be a very adaptable solution for modern living and working needs. Healthcare and education are two other sectors embracing modular with open arms. Hospitals and clinics can benefit enormously from the speed and controlled environment of modular construction, allowing for rapid expansion or the quick setup of specialized facilities with minimal disruption to existing operations. Imagine a new hospital wing being added in months, not years. Similarly, schools and university buildings, such as classrooms and student housing, can be erected quickly during holiday periods, ready for the new academic year. The quality control inherent in factory production is also a huge advantage for these critical public buildings, ensuring they are built to last. Modular construction also plays a crucial role in disaster relief efforts. When natural calamities strike, the need for emergency shelter and temporary housing is immediate and immense. Modular units can be rapidly manufactured and deployed to affected areas, providing safe and functional accommodation for displaced families. These structures can be designed to be robust and adaptable to various climates and terrains. The speed at which these relief buildings can be put up is often a lifeline for communities in crisis, offering a semblance of normality and security when it's needed most. It's a truly humanitarian application of this technology. The integration of technology is further propelling modular construction into the future. Building Information Modeling, or BIM, is a cornerstone of modern modular design and manufacturing. BIM provides a detailed three-dimensional digital representation of the building, allowing for precise planning, coordination, and clash detection before any physical work begins. This digital blueprint ensures that all components fit perfectly when assembled. Furthermore, the Internet of Things, or IoT, is starting to make its mark, with sensors being embedded into modules during manufacturing. These sensors can monitor everything from structural integrity to environmental conditions, providing valuable data throughout the building's life cycle. Going global prospects, hurdles, and the path ahead. Globally, several countries are leading the charge in the adoption of modular construction. Nations like Sweden and Japan have long histories of utilizing prefabricated and modular techniques, driven by factors such as harsh climates, skilled labor shortages, and a strong emphasis on efficiency and quality. In recent years, countries like the United Kingdom, the United States, Australia, and Singapore have also seen a significant surge in modular projects. This growing international interest is a clear indicator of the method's perceived benefits. The market projections are overwhelmingly positive, with analysts forecasting substantial growth in the global modular construction market in the coming decade, running into many billions of dollars. Despite its many advantages, modular construction does face some challenges that need careful consideration. The initial investment required to set up sophisticated modular manufacturing plants can be quite substantial, acting as a barrier to entry for some companies. Design flexibility can sometimes be perceived as a constraint, although advancements in technology are constantly pushing these boundaries, allowing for more bespoke and complex modular designs. Transportation of large modules from the factory to the construction site also requires careful logistical planning and can be limited by road infrastructure and regulations, especially for very large or oversized units. Regulatory frameworks and building codes can also pose hurdles. In some regions, existing regulations may not be fully adapted to the nuances of modular construction, leading to delays in approvals or requiring modifications to standard modular designs. Educating local authorities and updating codes to better accommodate off-site construction methods is an ongoing process. Furthermore, there's sometimes a lingering perception issue, with some people associating modular with outdated, poor-quality, prefabricated buildings of the past. Showcasing high-quality modern modular projects is crucial to overcoming this outdated image and building wider acceptance. In conclusion, modular construction is undeniably a forward-thinking approach that addresses many of the pressing needs of the modern building industry. Its ability to deliver projects faster, more efficiently, with higher quality, greater sustainability, and often at a lower overall cost makes it an incredibly compelling proposition. While challenges related to investment, design, perception, logistics, and regulation do exist, the ongoing innovations in technology and a growing global acceptance are steadily paving the way for its wider adoption. Modular construction isn't just a fleeting trend, it's a fundamental shift towards a smarter, more sustainable and more efficient way of creating the spaces where we live, work and learn. It's building the future one module at a time.